Hello again and welcome to this final lecture of structural equation modeling. In this lecture I want to teach you how to conduct multi-group analysis. So in this case we ended the previous video with this model, which includes both direct effect from social support to performance and also from social support to engagement and from engagement to performance. And of course, we calculated the model fit and the standardized estimates. And now we want to know whether or not these standardized estimates are similar or different between groups. And as an example, we will take males versus females, right? So you could say, is social support for male employees, does it have the same loading on, for instance, engagement and performance as compared to the standardized estimate of females? Are these models similar or are they significantly different from one another? Now, to perform multi-group analysis, you have to click here on group. You click twice, and then you want to compare the first group of, in this case, I coded it 0 females and 1 males in the data set, so we will start with females and then males, or male, whatever you like. Now you actually have to tell Amos what kind of coding you used, right? So you go here to select data file, and here it says already group name females. Now you can look at a variable, and the variable is actually in this case gender, and you can do the same thing for males. So you can refer to the same data set, SAM practice in this case, and so females are coded by 0, so you can put a group value here 0, and actually it already shows a group value for males, which is 1. So now you have 2 data sets with 296 observations, meaning that only the females are included, and 340 observations, meaning that only the males are included in that data file, right? And let's check to be sure. Did I really gender male or female? Oh, it's Dutch, I'm sorry about that. So 0 is female, vrouw, 1 is male, man, right? So, and now what we can do, first we can just run the model and see what happens. Okay, so the model is identified. So we click here. And now, we can actually just look at first glance whether or not standardized estimates are similar or very different from one another when comparing females and males. So let's look at that. So for instance, social support to engagement for females is 0.45, for males it is 0.49. Okay, very similar. Engagement to performance is 0.27 for males, and for females it's 0.36. Okay, somewhat different. A little bit higher, but not so different, right? And then finally, social support to performance for females is 0.34, and for males it is, wow, a bit higher, 0.48. And you can also maybe look at differences in explained variance. So for males we explain 43% of the variance in performance, and for females 35%, so somewhat less. But actually you also want to conduct a formal test. Okay, so actually we can conduct a chi-square difference test. So we should first write down the chi-square and the degrees of freedom for this model. So we have 725.061. Chi-square and degrees of freedom 365. So I put them down here. 625.06. Let's include the 1. 1 and 356 degrees of freedom. So now what we're going to do is constrain the paths of the model. So actually you can click on the arrow and go to parameters, and for each regression weight you should fill out a letter, so A, B, C in this case, right? So now you tell actually Amos to estimate this model as if the path coefficients were similar for males as compared to females. And then Amos will compare how well that model with the constrained paths will fit to your data. So let's run it. Okay, it identified the model. And now we actually have a chi-square that is a little bit higher, 7 to 9.47. So let's fill it out. 7 to 9.47. And 359 degrees of freedom. So we compare now this chi-square of the constrained model. Constrained model, df. Nope. df, delete. With the unconstrained model. So you see the chi-square difference is 4.409, and the difference in the degrees of freedom is 3. So we have an insignificant p-value. So meaning that the constrained model here, it fits at least in terms of chi-square, it fits equally well to the data as compared to an unconstrained model. And from that you can conclude that there are no significant differences, at least when it comes down to these path coefficients between females and males. So that's one final analysis you can do. So when you want to compare multi-group differences, you can enter the groups here. In the file you can identify which groups you want to compare. Then you can run an unconstrained model in which you just are going to look at the standardized estimates and the unstandardized estimates at first glance. And a formal test for multi-group analysis would be to constrain the paths, to run the analysis twice, an unconstrained model and a constrained model, and then you calculate the chi-square difference test. Okay. That's it. Maybe one final remark. We now only constrained the paths. So we have concluded that in terms of the structural model, there are no differences between females and males. But of course you can also constrain factor loadings, right? So you could also look at whether the measurement model varies between females and males by constraining loadings from the factor loadings on from the unobserved to the observed variables. But we are not going to cover that in this video lecture, so just so you know that these possibilities are also there. So I hope these video lectures are useful for you and for your group, and I hope they are useful also in terms of making group assignments too a success. And okay, thank you for listening.